welcome to the second part of the lecture on quadratics. In this video we're going to go over completing the square, and this will lead into the very familiar quadratic formula for next time. So for right now, completing the square, we're going to consider the problem right here that we have. And note how easy it is to solve a problem once it's set up like this. All we have to do is rearrange this guy so that it says x minus 3 squared, and then we add a 4 to both sides, and now we have a nice simple problem. Now a common mistake I see a lot of people doing is they'll take a look at this and they'll expand it and then they'll work through it after that, and it's still, there are some things you can do if you do that, but it's kind of doing extra work that you don't have to do. So if you already have it like this, do not expand it. You are just creating more work for yourself. So instead, you want to go ahead and bring the 4 over, like we have right here. And then note, all we have to do now is take the square root of both sides. And when you do that, you take the square root of both sides. You got x minus 3, because you're taking the square. The square root of a square is itself. And then the square root of 4 is positive or negative 2. And we should probably go ahead and put positive and negative right before it as well. Alright, and then when you solve it, you simply write x equals 3 plus or minus 2. Or equivalently, we could write 3 minus 2, which is 1, and 3 plus 2, which is 5. Alright, so note, once it's in this form here, how simple things are to work. And this is going to be the goal when we're working with general quadratic equations, is to get something that is akin to this formula here. So we want to go ahead and look at this in the more general sense. So let's go ahead and write this as so we've got expression x plus k quantity squared is a simpler form of the quadratic equation, which is ax squared plus bx plus c. Oh, don't forget equals 0 equals 0. We can say that these two terms are equivalent because, of course, you can divide everything in this equation by a, and then you will get this guy right here. So let's go ahead and take a look at these things more generally. Okay, so we've got ax squared plus bx plus c equals 0, right? This is what we have. But what we want is to have something that looks like this. X plus some constant quantity squared, and we want that to equal just some number, right? So that way, because this is what we had up here, because when we have it like this is easy to work with. So we want to convert what we have right here into something that looks more like this. And if we have that, well, then this becomes a very easy problem to work with. So first, let's go ahead and examine what we want. We're going to go ahead and expand this term here so that we kind of have a goal to shoot for from over here, right? We're going to be working with this side here to make it look more like what we have here. So let's go ahead and do that. So we've got x squared plus 2 times k times x plus k squared equals 0. Alright, so this is the form that we want everything to look like. Okay, so let's go ahead and come back over here. So what's the first thing we got to do to this guy to make it look like this guy? Well, we need to divide by a. So let's go ahead and do that. We're going to go ahead and divide everything by a. Right, so that's our first step. And so when you do that, you've got x squared plus b divided by a times x plus c divided by a, and that equals 0. All right, let's go ahead and just rename these things, because, you know, one constant divided by another constant is just, it's still a constant, right? So we're just going to go and rename them. And we'll go ahead and call this a capital B, and let's just go ahead and just call this a capital C. All right, and so now we subtracted this constant over so that we get something that looks like this: x squared plus our big B times x equals negative c, right? And so all we did was just simply subtract our big C. All right. Oh, sorry. Let me get this back. Why is this thing going crazy? Oh, wrong thing. What is going? Where did it go? What the hell? It was here, then it just disappeared. Alright, so now let's go ahead and take a look at what we have. You know, we're going to take a closely examine this guy right here. And closely examine this guy right there. The big idea that we're trying to do here is that we're trying to get this one and this one to have the same form. And so note that one of the big differences between these two guys is this 2 right there. And so we want to get a 2 over here. So what we do is we're going to go ahead and put a 2 here. But if we're going to multiply it by 2, we also have to divide it by 2. Alright? So we've got a similar form here. Now, note that over here, this k, well, this k is also present right there. So if we want to get these two guys to have the same form, well, then we got to add in that part there. So note that we're going to add in what's highlighted in green, and then we're going to square it. So this is going to be plus our big B divided by 2, and then we got to square it. So note that when we do these things, this has the same form. Now, very important that when you add something into one side, you got to add it to the other. Okay. Awesome. Okay, so this on the right hand side, the C is a number, B is a number. All this is just going to be on the right, just some number. Don't worry about the specifics of it. We're going to get more into these actual numbers later on. For right now, just know that this is just some number. And now over here, we want to go ahead and note that these two that I've just circled here now have the same form. Right, you can see the green, you can see the 2 present in both of these. So all we have to do is get our k right. Well, note that at this point I just got to rewrite this guy here. All I'm going to do is rewrite him. And so when I do that, I'm going to say x plus something squared. And I just got to write in the green. Over here it was k, over here it is b divided by 2. And then note from here, if you wanted to work this, all you would do is you would take the square root and then solve. Okay, and that's it. steps. That's the overview. Alright, so now that we have a general idea of the formula that this involves, let's work an example. So that solidifies, and then on the other side of this handout we're going to go through a baby step portion of the handout that I encourage you to try and work on your own before listening to the rest of the video. But for right now, we're going to work this problem here right now. Okay, so first thing we notice, we got a number in front. We want to get rid of that, so we're going to divide by that number. And so we have x squared plus 3 divided by 2 times x plus 5 equals 0. Oh, don't forget to, there we go. Alright, now we want to go ahead and send that guy over. And so you get x squared plus 3/2 times x times negative 5 over 2. So like we did before, we're going to look at this number. We multiply it by 2, and then we divide it by 2. Alright, that's how that works. And let's go ahead and just rewrite this one for simplicity's sake. We get x squared plus 2 times 3/4 times x is negative 5/2. Okay, so note that we've got our number right there. Right, that's what we need to use to complete the square. So we add this number to both sides, and keep in mind we don't just add it, we add the square of it like that. Cool. So now we go ahead and simplify the left hand side. Note that we've got everything as it should be here. So we have an x plus something there. And what is that something? Well, the green highlight should be a good indicator. 3/4. And then over here we're just going to go ahead and work this through. We've got negative 5/2 plus 9/16. And then we need to go ahead and get a common denominator here. So we have a 8 over 8 to get these the same. And so this simply becomes negative 40 and then on the bottom 16, and then we have plus 9 over 16. So common denominator, negative 40 plus 9 gives us negative 36 divided by 16. Now you can reduce this, of course, but we're going to leave it like this for right now because we're going to take the square root. Note 36 and 16 are both perfect squares. And so we take the square root of both sides. So we got x plus 3/4 equals positive or negative square root of negative 36/16. And so this becomes positive or negative 6, and 6 times 6 is 36, and on the bottom that's 4, and don't forget to include the I in there. That's because the negative and where the I does mean the square root of negative 1. Alright, so now we just work this over. So we have x equals negative 3/4 plus or minus 6/4 times I. And there we go. That's it. That's the answer. Alright, so let's review the steps, shall we? Note that the first thing we did was we divided by a, which was the 2. And then the next thing we did was that we multiplied and divided the second number by 2. And once we did that, that gave us the number the number that we needed to complete the square with right over here, and note we did it to both sides. And then after that, it was simply a matter of taking the square of both sides and solving. And that's it. That's how we did it. Okay, so now what I was talking about before, we do have a completing the square handout where it kind of just baby steps your way through it. Go ahead and try and hit the pause button and work through as much of this part as you can. I'm going to go ahead and work it through in the video, but just try and get as far as you can. If you get stuck, go ahead and play it until the point that you're at, and then we'll go from there. So right now, let's go ahead and knock this out. Now divide every term of the equation by the lead coefficient, which is 3. Right, there it is. That's what we're looking for. This will give you x squared minus 1 over 3 minus 2/3. Okay? Add the constant coefficient, and the constant coefficient is simply going to be this guy right there. Or using green, let's go ahead and do that with blue. All right, that's going to be the constant coefficient. Well, should I say this is the original constant coefficient. This is what the constant coefficient becomes. So 2/3. There we go. All right. Now take the new second coefficient. Keep in mind that's the new second coefficient right there. And place it in the first blank of the following equation. So note this is exactly what we're doing before, right? We're multiplying and then dividing by 2. And so when you do this, you get negative 1 over 6. And so note that if you evaluate this out, you will get this guy over here, negative 1/3. Okay. So now let's use the results of the right-hand side of the above equation to fill in the blank. Okay, so we're simply writing in negative 1 over 6. Like so. Note, nothing's changed. The form of the numbers changed, but so far everything is the same. Now we're going to add in the square of that number to both sides, just like we did before. Negative 1 over 6, negative 1 over 6. And now we start to work everything through. Note that, we again just put that there. And then again, same thing over here. So all that changed over here was the left-hand side. Right-hand side stays the same. Okay. All right, so here we're going to evaluate the right-hand side. So let's go ahead and just kind of use this area to do some scratch work. We've got 2/3 plus 1 over 6 squared. So we have 1 over 36. Note the negative became a positive because of this guy here. And now we simply have to get a common denominator. 3 times 12 will get us 36. So we want to do 12 over 12. And so we end up with 24 over 36 plus 1 over 36. And we get the nice perfect square number, 25 over 36. So let's put that in here. Now we take the square root of both sides. And then when you evaluate that, you get positive or negative 5 over 6, just like you do right there. And then from here, you just simply simplify this number. All right, so first we're going to subtract 1 minus 5, so that is negative 4. And then we're going to add the 5 in so that we've got 6 over 6. And so we get negative 2 over 3, and then a 1 right there. Alright. Go ahead and use the back of this handout if you've printed it off to rework this problem without the aid of this worksheet, and things should start to really click at that point. Okay, so make sure you do get some practice with completing the square. In the next video, we're going to go over the quadratic formula. And the quadratic formula we will see is simply a generalization of completing the square. So I will see you guys in the next video.